The diagram shows a large equilateral triangle divided into 36 small equilateral triangles with area 1 centimeter square. What is the area of the shaded triangle in centimeters square? So this question, I have done it a bit differently, and it may not be something, or it may not be the way in which you'd want to do it all the time, but anyway, it's a bit different. So just to give a warning. However, I would maybe you would like to watch the video and follow through the entire method. But I did get the right answer, so I thought I might show you. So this is what I did. So now they have given us the area of each of the smaller triangles is 1 centimeter square, and so the area of the entire rectangle would be 36 centimeters square. And if somehow I could find the area of these white parts and then subtract it from 36, then I should get the area of the shaded part. So that's what I did. That's the logic. So I would start with finding the side of each of these, these triangles. So what is the side? So when they say the area is 1 centimeter square, that means that area of equilateral triangle root 3 out of 4 times a square. If the a is the side, so if I say a equals side length of the smaller equilateral triangles, and that would be equal to, so I'll work it out, so that equals 1, so therefore a square would be 4 out of root 3, and then we'd have a equals the square root of the whole thing, and that would be 2 out of 3 to the power half. I write it as 3 to the power half times half, and that is 2 divided by 3 to the power 1 out of 4, and that is the side. So that would be right there, 2 out of 3 to the power 1 out of 4, and that is a on the side length. So we now know the side length, so we can work out what each of these sides are. Okay, but now to find the area of this triangle, we have the base. Now we need the height. Now how will we work out the height? So if we were to draw the equilateral triangle on its own, and you know that an equilateral triangle is also an isosceles triangle, so what I would do is, so if I were to draw it out, it's a very rough drawing, so then I am going to draw the perpendicular, and it's a perpendicular bisector of the base. It doesn't look like that in my drawing, sorry about that, but it is the perpendicular bisector. Bx would be equal to xc, because ABC is equilateral, is the small equilateral triangle. So if I say that, so then AC we already know, it is 2 out of 3 to the power 1 out of 4. Then you would have XC, so I can write XC as 2 out of 3 to the power 1 out of 4 divided by 2, and that would mean it is multiplied by half, and that would mean it is equal to 1 out of 3 to the power 1 out of 4. So that is XC, and that is the hypotenuse. AC is the hypotenuse, so AX is the height. So then H would be the square root of, write it nicely, H equals, so the square root of 2 out of 3 to the power 1 out of 4 whole square minus 1 out of 3 to the power 1 out of 4 whole square. And then what we get is, see, that is equal to square root of 4 to the 4 out of, sorry, 3 to the power 1 out of 2, okay, because 3 to the power 1 out of 4 whole square is 3 to the power 2 out of 4, and that is 3 to the power 1 out of 2, right? So then this minus 1 out of 3 to the power 1 out of 2, and that is equal to nothing but 4 minus 1 is 3 out of 3 to the power half, and that can be written as 3 to the power 1 minus half, and that can be written as 3 to the power half. So, and then that equals 3 to the power 1 out of 4. So the height h, I can write it as that the height h is 3 to the power 1 out of 4. And so we have got the side length, we have got the base, we have the height. So we have got to just name this triangle, and we'll work out each of the areas of the white parts. Okay, so it's a bit long, so anyway, I'll do that. So if you have A, and I could call it B, C, and then D, E, F, right? So then let's start with area of BDC. So area of triangle BDC would be half times the base. Now the base we know, isn't it? We know what this length is, and we know what this length is. So there is 2. So there's 2 of these, 2 of the 2 bases or 2 lines. If I say half times, the base would be 2 times, and this one, the side A, whatever we got as A, so that would be 2 out of 3 to the power 1 out of 4, and then I need to multiply it with the height. Now what is the height? So you see the height is, this is the height, so let me get a colored pen. So this is the height, 1 height, 2, 3. So the height is equal to the height of 3 equilateral triangles, 1, 2, 3. So I can say it is equal to 3 multiplied by 3 to the power 1 out of 4. And you see that equals. Now notice that this 3 to the power 1 out of 4, 3 to the power 1 out of 4 would cancel out. The 2 and 2 cancel out, and I'm left with 6. So I can say that area of triangle BDC equals 6 centimeters square. So then I'm going to work out the area of triangle FED, that's this one. So area of triangle FED, that is equal to, once again, half times base. So base is how much? 1, 2, 3, 4, goes up to the point D. So that's 4 times 2 out of 3 to the power 1 out of 4 multiplied by the height. Now in this case, you see the height is only the height of one equilateral triangle. This is the height. So the height will be 3 to the power 1 out of 4. So once again, you see that these cancel out, 2 and 2 go, and I'm left with 4. So area of triangle FED equals 4 centimeters square. So then I am going to work out the area of the other white bit, so which is this one. So that is triangle AFB. So I'm going to write AFB. So the area of triangle AFB would be again half times the base. So what is the base? 1, 2, 3, 4, 5. So 5 times 2 out of 3 to the power 1 out of 4 times the height. Now this is something we need to really be careful about. Now height is, now you see when you do the heights, we're doing the heights of these equilateral triangles. So this is the height 1, 2 and 3. So this is the perpendicular. So we got one triangle, we got another triangle, we got another triangle. So that would be 3 times and 3 to the power 1 out of 4. And what does this give us? This would give us the 3 to the power 1 out of 4 would cancel out, and the 2 and 2 go, and 5 times 3 is 15. So we get area of triangle AFB would be equal to 15 centimeters square. So all done. Now the final step, and we see if we can get a proper answer. But you see how magically the 3 to the power 1 out of 4 just disappears. We do. It's sort of, doesn't cause any problem at all. So now finally the area of the shaded part would be, so we can say area of the shaded part would be equal to, so we have 36. The area of the large triangle is 36. I didn't write that. Area of the large triangle equals 36 centimeters square. So shaded part would be 36 minus 6 plus 4 plus 15, and that equals 36 minus 10 plus 15 is 25, and that equals 11 centimeters square. And that is the answer, the area of the shaded part. So that's it really. Thank you very much for viewing. Thank you for your time, and please subscribe. And if you're interested in more maths problem solving videos, please visit my channel at HypatiaMath147. Thank you.